Hi everyone, and welcome to the next Synte video. So one thing to bear in mind when using this is that I still don't know whether to call it software or an environment or whatever, but anyway, one thing to bear in mind is that it is a functional prototype. It's not like a polished version. It is mainly for the purposes of kind of developing the language. And so, you know, there's going to be constant rolling changes. The kind of bulk of it is there, which is why I've chosen now to start kind of sharing it about. But there will be things that, as I kind of do these videos and as other people use it, things will crop up of like tweaks, changes, all kinds of things. So bear that in mind. At some point in the video, might pause to make some notes for that reason. So let's get into this now. I had a look at my surf code that I mentioned in the last video, and I think if I recall correctly, this what I'm typing in now should work. Hopefully the video quality is better on this one as well. So the way I originally conceived this kind of waves on a beach sound, so you've got this kind of rising and falling pseudo-random noise pattern. Now that on itself is a little bit repetitive, so what you can do, add in more kind of layers along similar lines, usually try and tweak the parameters slightly. Now what I've noticed is this odd effect where I've kind of got, this is how I interact with the program. If I'm typing out a kind of de novo listing something, I'm just trying to create something out of nothing that I've not tried before, I actually find it easier than trying to replicate something that I've done before. And like when I was typing in the second one of those, even I was kind of referencing the one I've written before, which is kind of interesting effect. Don't know if it has any bearing on anything, but hopefully now you're feeling nice and relaxed by the beach. While this isn't particularly musical, you know, these kinds of patterns could easily be adapted for more musical purposes. So anyway, right, so now I don't know if I mentioned last time, but when you type out a listing, you type in a series of operators with an operand, just one operand, unless it's a function, which I'll go into more detail another time. You type in the series of those, and then there's two main operators which will actually end the listing and launch it to the sound engine kind of automatically, so you don't have to like type end or type, you know, run this or anything. It detects that these things will, you know, end the listing. One of those is what you can see on the screen now, which is out, but specifically only out DAC. Now DAC stands for digital audio conversion, which is basically a way of saying your sound card. So, you know, you're sending it out to the sound card. Synte's like, okay, cool, right, let's execute that. But actually, it's been superseded by a function called mix, which contains out DAC but adds another operator inside. And what mix does is it helps you set a sensible level. Now I think I did mention this in a previous video, but I mean, I've got no qualms about repeating myself, as like I don't expect everyone to watch every single one of these videos. So yeah, mix will have the same effect. And then there's other ones like if you want to end a listing but you also want to mute another one and do the same thing, you know, both those things at the same time, what you can do is type .mute. Now I'll demonstrate that by typing in a really boring sine wave. Now what I'm going to do is .mute and then let's mute 1, which is the last one we added. Now I press enter, it's submitted it to the sound engine and it's muted 1. And likewise you could do the same thing again. Let's mute 0. Now it doesn't actually send mute, it just performs the mute action, adds mix to the end of the listing, and then the listing is sent. So it just kind of combines two operations, partly for convenience, but partly because you might want to, you know, really kind of like add this, take that out at the same time. You can also do the same thing with solo and delete as well. Now I guess the difference between mute and delete is that mute something if you want to kind of unmute it in future. If you've made a mistake or you're bored of something, then you can just delete it. And when you do delete it, that kind of number will just disappear, the index of the listing, which is on the left of the listings display. So the most recent listing that's been submitted to the sound engine will also, the index of that will also be the actual number of listings that you've sent minus 1. So I've 3 is the largest or the greatest index I've got there, and I've got 4 in total that I've actually sent. Anyway, this is all pretty boring stuff, so let's get on to let's do some echo. Now each listing contains its own tape loop, which you can access using the tape operator. So let's write, like if I feed one of the pre-existing listings into tape, then it's not going to really do much because it's quite a kind of consistent sound. It would work on the surf sounds, but it'd be a bit incoherent because you kind of noise is basically definition of non-coherent waveform. So what I'm going to do is quickly type out a kind of pulsed thing that will kind of just beep intermittently, so we can kind of hear the sound of the delay. So I'm setting a tempo, divided by 4, so I'm assuming 4 beats per bar, so this is going to trigger like once per bar. And then we're going to do a pulse, quite a narrow pulse. And let's add a touch of slew to it. Slew is a way of slowing down the kind of rise and fall times of a waveform. And then what we want to do is send that out to, usually do is type out VCA. Now that means that in the VCA kind of register or signal, that's like a kind of pipe or a kind of like a connection that you can pick up somewhere else in the program. So now we'll do 440 Hz. Now it's going to play a sine wave. If we multiply by VCA, and we're going to gate that, we're going to turn it on and off. We're going to use the one waveform to control the volume of the other waveform effectively. And then now just send that to the sound engine. So that's quite a nice little beep. Sounds quite a lot like the Greenwich Meridian time signal, I think it is, whatever they put on before the news on Radio 4. So let's solo that. Now we're going to take this beep and make it kind of echo a bit. So I'm going to use the from operator, which takes the output from listing 4 and makes it the input of this one, so you can kind of chain listings together. Ideally in future I'd want a way to do the reverse, where you can send the output of a new listing into the input of a different listing, but that's a little bit more complicated because you kind of need to be able to specify at which point it enters, and it's a bit tricky, that one. That's something that I have to work on building up a kind of decent concept first. So right, first thing we're going to do is add the feedback. Now we haven't made the feedback yet, that'll come later, but we need to add it in now. And then we're going to send it to tape 1. The 1 just means play at normal speed, and if it's a number less than 1, like 0.3 or something, then the output is of the tape is going to play slower than the input, which is something you can't really do with normal tape. But it's effectively like putting your finger on the spool of the tape to slow it down, except it can do that ad infinitum because it's still recording in a consistent speed. And if it was tape 2, then it would double the speed of the playback. It's something you don't really need to use a lot, it's just there as a feature. I've thought about removing it, to be honest with you, but so the output of tape is just that's pitched up or slowed down signal with no offset. So you could use that for things like generating chorusing or flanging. But we want to actually introduce a delay, so we're going to tap the tape. Tap just means taking a kind of tap of the data off at a slightly different offset. And then, let's choose 125 milliseconds as our time. And then really we want to attenuate this slightly, turn it down in volume before we feed it back. Otherwise it could become a kind of positive feedback loop where it just starts like distorting and getting really loud. It won't, it'll never go above the value of 1 because it will clip. It just won't sound necessarily that great. But what I'm going to do is cheat slightly and use the mouse X special signal, which you can't write to mouse X, but you can take it in as a value, and it basically gives the value of this X coordinate of the mouse at the bottom. So I'm going to use that to control the level of the feedback, so you can kind of see what different levels do, or even different polarities. So now I'm going to go out, feed, back, and then because I've already mixed the listing that this is coming from, I'm just going to do out, stack, and hope that this works. So now you can hear the delay. I'm getting close to 1, and as I go over 1, it will start to really kind of loop round, and it's kind of merging into itself. Now, tape is something that I've got working, but it probably there seems to be certain oddities about it that might be worth preserving, but it doesn't seem to quite happen in exactly the way you'd expect. We're now going into negative polarity. I quite like the sound of that. That's actually a negative polarity. So it's kind of flipping the waveform upside down before it sends it back to the feedback. So, you can do nice things like that, and it has a lot of possibilities. It might seem that certain things in certain things in Synte seem to be a bit clunky or overly elaborate. Now, that's not like a design feature per se, but the whole idea is that the language is based on a list of, it's about 40 now, operators that you probably only want to regularly use, like, less than half of them, maybe only a dozen. And these give you the building blocks, but you can make things from those building blocks that you then can use as building blocks. And as I mentioned in the last video, part of the process of kind of developing Synte further is to create this kind of library of these other building blocks, so it becomes less wordy. So, like, in theory, you could have a delay function which could encapsulate basically what I've just typed in there, and it would have a argument or an operand which might be the delay time. And the thing about functions is that they can actually have more than one argument. So if I Euclid is actually a function, and you can see I've separated 3 arguments by commas. Each of the arguments is equivalent to 1 operand that you'd use for an operator. But it basically just expands possibilities of functions. Because functions contain a lot of other stuff, you kind of really need to be able to like put more stuff into it. So in terms of Euclid, 3 and 8 are your kind of parameters of this Euclidean rhythm kind of generator, and 0 is actually just simply a phase offset. It basically delays the onset of the initial start of the sequence, so you can play around with so if it's 0, it's just going to start on the beat. If it's half, then it will start halfway through the bar if that's what it syncs to. Now at the moment, it's what I've typed in there is 120 BPM. Now it's gonna think with Euclid, it will play like a sequence for each beat of the bar then. So let's just divide by 4 as we did earlier. Now hopefully I've remembered this right. I might actually just quickly reference this is some code you can see on the screen. So I'm just quickly going to reference the documentation. In the examples it's got multiply by a quarter, which is equivalent to divide by 4. For a long time I actually didn't include the divide operator because I thought be able to just use fractions, but it did get to the point where I needed to use it for some things. So it got added in the end. But as I joked to myself, I'm not about creating divisions. So it looks, according to this example, we're on the right track. Let's just replicate that example because it works quite nicely. So Decay takes a kind of trigger. So as the output of Euclid is a series of pulses that correspond to these like Euclidean rhythms. Decay will trigger on, I think it's on the rising edge of a pulse, and then it will decay away, as the name suggests, until it meets another rising edge. And I'm going to use that to control the volume of a noise. Now noise, because you don't input a frequency into it, because it's all frequencies, I found it convenient to actually have the input to noise controls the volume of it. It just makes the signal chains a lot more effective. So there's noise, and then let's do mix. Let's just solo that. Now, I did change the way mix handles noise recently, and I think I was a little bit over the top with it. So I'm just gonna actually, let's erase. What I'm gonna do is turn up the volume of that by 12 decibels. So in 12 decibels, and then I'm gonna send that to dot level 6, which is the index of that one. That's increased the level, and then I can now delete that listing because it's kind of done its work. So you can hear that classic rhythm. I can't remember, there's all kinds of names for it, but if, you know, say I wanted to make a kick, Then let's do a kick, and we'll do it on every beat of the bar. Now what I'm going to do is just flip a ramp wave, and that'll become our kind of envelope. And then let's use X to kind of make it exponential. And then I'm going to multiply it by, let's go for 65 Hertz. And then I'm going to use that envelope to control the pitch of an oscillator. So this pitch of the oscillator is going to go from 65 down to 0 times 65, which is 0. So it's going to be a decreasing pitch envelope. If I'd done out VCA after X, then I could use that to like add like a volume envelope, but I decided not to in this case. Now we're going to multiply that by 3, the waveform, which is going to expand it, and then we're going to feed it into tan H, which is the hyperbolic tangent function, which sounds very fancy, but basically it's a kind of, it's a nice way of distorting things. It's not too harsh, it's quite progressive, and yeah, it's quite similar to the way transistors distort. Distortion is something I want to explore in future, so it's possible that I might add in other operators in future for more kind of exotic forms of distortion. Now let's just control the level of this with mouse Y, and then if I just take mouse Y down, then yeah, let's mix that. Now that sounds like a bit of a mess at the moment because they're not synchronized. So let's oh, I can't synchronize them. Let's just solo. I'm going to use POSC instead of OSC here, so then that enables me to synchronize it, which requires the argument, which is the offset. Anyway, you don't need to remember all of this. I'm just trying to give you a general overview, and this time I'm going to apply VCA. I'm going to actually make this a sine wave as well. Let's do a 909 style triangle, distorted triangle, which oddly enough, when you distort a triangle wave in a particular way, it becomes more closer to a sine wave. A bit counterintuitive. And then let's delete 8. Let me check my this be the case. Just going going to take that up a bit. Apologies if this goes a bit loud. Should really monitor this on headphones. Actually, I'm going to do that right now. So those don't seem to correspond in any way. Let's try syncing them up. Now they're playing in time. Something I didn't quite expect happened there, but get the general picture. I think it's probably going to be quite a consistent theme of these videos, is that I'm going to end on a bit of a dodgy note. So probably my brain gets tired, which doesn't really bode that well. Ooh. Done some. You can also do verbose mode. The screen's just gone crazy, but this is showing the kind of underlying unwrapped functions, so the kind of raw code of Synte, which maybe has a certain aesthetic, but isn't, particularly easy to understand. So I'm just gonna I know why that's not working. Do I? I'm just trying to replicate this in a way that works, so to tolerate some silence. In fact, let's unmute the surf sounds so you've got something to take your attention. This error warning shouldn't actually occur. Yeah, actually I'm going to make a note of that. Okay, right, let's carry on. not updated this function to account for the type system, that's why. And let's just quickly. Here I'm adding a touch of distortion, the tan H, but I'm like turning it down in volume so it's in a more linear region of tan H, and then afterwards turning it back up again. It doesn't be doing that because of the new type checking, but if that, then this gives a slight word of caution. Now let's do go. Someone's calling you. And on that bombshell, I think I shall end this stream. Thanks for watching. See you soon.